Welcome to the DIY Honda Garage channel. The DTC P2A00 indicates an issue with the air-fuel A sensor, particularly sensor 1, which is responsible for monitoring the air-fuel ratio in the engine. When the voltage output from this sensor deviates significantly from expected levels during a deceleration phase, the Powertrain Control Module, PCM, identifies this as an anomaly and records the Diagnostic Trouble Code, DTC. Sensor 1 is typically located in the exhaust manifold or near the engine, allowing it to effectively measure the oxygen concentration in the exhaust gases and relay that information to the PCM for optimal engine performance. Understanding this code is crucial for diagnosing potential fuel efficiency problems, increased emissions, or rough engine idle. The PCM relies on accurate readings to adjust fuel injection and ignition timing, ensuring the engine runs efficiently. The corrective actions can directly impact vehicle reliability and environmental compliance. The P2A00 code specifically points to a malfunction in the A/F sensor, also known as an oxygen sensor, which is crucial in measuring the concentration of oxygen in the exhaust gases. Positioned in the exhaust system, often after the exhaust manifold, sensor 1 provides vital feedback to the PCM. This feedback is used to adjust fuel delivery and ignition timing for optimal combustion. If the sensor's output voltage strays from predefined parameters, likely due to a faulty sensor or exhaust system issue, the PCM logs the P2A00 code. An accurate air-fuel mixture is essential for efficient engine operation and emissions control, and a malfunctioning sensor can lead to increased fuel consumption and emissions problems. Therefore, inspecting and possibly replacing the A/F sensor, sensor 1, is necessary when this DTC is encountered. Several potential causes can trigger the P2A00 code. The first and foremost reason is a faulty AF sensor, sensor 1, which may suffer from electrical issues that prevent it from sending accurate readings to the PCM. Wiring problems, such as frayed or exposed wires, can also create poor connections, leading to erroneous voltage signals. Additionally, exhaust leaks can affect the sensor's ability to accurately determine the air-fuel mixture, as outside air may skew the readings. Other causes, such as issues with the PCM itself or contamination on the sensor due to carbon buildup or oil leakage, can also play a role. It's vital to thoroughly inspect all these components to identify and rectify the underlying cause effectively. The presence of DTC P2A00 may manifest in various symptoms noticeable to the driver. A common symptom is a rough engine idle, which occurs when the air-fuel mixture is not being regulated correctly, leading to instability in engine operation. This can be particularly frustrating during stop-and-go traffic or at idle. Increased fuel consumption is another potential issue, as a malfunctioning AF sensor may cause the engine to run richer than necessary, leading to wasted fuel and elevated operating costs. Additionally, drivers may notice poor acceleration performance, making driving feel less responsive and diminishing overall driving experience. Jumps in the RPM during common driving conditions can also be indicative of issues related to the AF sensor, further confirming the diagnosis of the P2A00 code. The first step in troubleshooting DTC P2A00 is to start the engine and hold the engine speed at 3,000 RPM without any load, which means the vehicle should be in park or neutral N gear. This action allows the engine to reach a consistent operating condition necessary for diagnostics. While maintaining this RPM, it is important to watch the vehicle's radiator fan engage, indicating the cooling system is operating correctly under these conditions. Once this is confirmed, the procedure requires letting the engine idle to stabilize. This preliminary step paves the way for meaningful data collection needed to diagnose the AF sensor's functionality, ensuring that conditions are ripe for accurate readings. Monitoring the HDS, Honda Diagnostic System, data during this process offers vital information about the engine's performance and the status of the sensor. The second step involves a comprehensive test drive under specific conditions while monitoring critical data from the HDS. It is crucial to ensure that the engine coolant temperature, ECT sensor 1, reading is above 158 degrees Fahrenheit, 70 degrees Celsius, to confirm that the engine is at an ideal operating temperature. During the test drive, the vehicle must be in drive mode and should achieve speeds ranging from 25 to 55 miles per hour, 40 to 90 kilometers per hour, for a duration of 5 minutes. Following this, the vehicle should then be driven at a steady speed between 55 to 75 miles per hour, 90 to 120 kilometers per hour, for at least 10 seconds. After maintaining the steady speed, a full deceleration should occur for over 5 seconds with the throttle fully closed. All these conditions are essential to see how the AF sensor behaves in various situations. Collecting data reflected in the OBD status, onboard diagnostic status, of the PGM-FI, programmed fuel injection system. Once repairs have been made, or the AF sensor, sensor 1, has been replaced, confirming the effectiveness of the repair is critical. Begin by clearing the DTC via the HDS, which removes the stored fault codes from the system, enabling a fresh start for diagnostic testing. Following this, a comprehensive test drive is essential to ensure that the circumstances leading to the P2A00 code do not reoccur. During this test drive, closely monitor the system for any abnormalities in engine performance, making sure that the air-fuel mixture is effectively balanced and the engine runs smoothly. Successful verification is indicated by the absence of the P2A00 code in the OBD status, ensuring that the vehicle operates efficiently under all tested conditions. This verification process is vital in confirming that the repairs have resolved the underlying issue. Preventive maintenance plays a significant role in avoiding issues related to the AF sensor and the subsequent P2A00 code. Regular checks of the AF sensor can help catch potential problems before they escalate, ensuring the sensor is functioning accurately. Scheduling routine engine diagnostics is also essential, as this includes scanning for DTCs, monitoring data parameters, and inspecting the entire fuel system for issues. Keeping a close eye on the exhaust system eliminates leaks that can affect sensor performance. Additionally, maintaining the proper engine operation through timely oil changes, air filter replacements, and fuel system cleaning can further enhance the lifespan and efficiency of the AF sensor. Proactive measures such as these can significantly reduce the likelihood of future faults, ensuring the vehicle remains in optimal working condition. In conclusion, the DTC P2A00 highlights a significant issue with the A-fuel sensor, Sensor 1, which is integral to an efficient engine performance. This troubleshooting guide emphasizes the importance of understanding the sensor's role in monitoring the air-fuel mixture for optimal combustion duration. Regular diagnostics and vigilant monitoring can catch issues early, ultimately saving on repair costs and improving vehicle performance. Following the outlined troubleshooting steps ensures a systematic approach to identifying and rectifying the cause of the fault. Engaging in proactive maintenance practices further enhances the reliability of not only the A-fuel sensor, but the entire engine system. Staying ahead of potential problems can lead to a smoother, more efficient driving experience, making it an essential focus for any Honda CR-V owner. Please like and subscribe to the channel. See you next time.